My name is Matt DeBergails. I'm one of the authors of Meteor, and what I wanted to do today was just talk a little bit about where we've been for the past year, the roadmap to 1.0, and then focus most of the time on two things. One is I'd like to talk about our recent work on packaging, which is something that will be coming out, I think this week actually, as version 0.6.0. We have a lot of exciting stuff to say and show on that. And the other is just to leave time for questions. I hope that you have some. I've always enjoyed this as more of a back and forth. So I'll keep my remarks fairly brief, and then we can kind of take this in whatever direction you guys are most interested in. So Meteor is a platform for building applications in JavaScript. And for those of you who've had a chance to play with it, I think you'll understand what I mean when I say that it's radically faster than really anything else out there for building native HTML5 apps, where most of your code is written in JavaScript or CoffeeScript and runs inside the browser or inside something like Titanium, rather than on the server the way that we've written web apps for the past 10 or 15 years. And I don't want to dwell too much on the motivations there. There's a trend, I think, quite clearly toward software moving from the server to the client. It's a massive change, it turns out. And something I like to talk about is how when we make transitions like this in the computer industry, and the rise of the web, the move from Windows software to the web was the last one of these. When we make these changes, it not only changes the applications, but it disrupts the stacks that we use to build them. And so I think what we've all struggled with for the last couple years, and the reason that you're all here, is the challenge of how do we build this new style of application that's just fundamentally different than the tooling and the practices that we've learned over the last 10 years building for a server-centric environment. I don't want to dwell too much on that because I think we've already read that gospel and we all believe it. The other thing I don't want to dwell too much on, but it's worth touching on for just a second, is why it's so damn hard. It's way too hard to write an application like this, and part of the reason I think boils down to an inconsistency between the tools that we use and the needs of the architecture that we're pursuing. And just to give a little bit of color, I'll pick one example, which is the wire protocol, or the network interface that we use between the client and the server. So the web, of course, grew up around a protocol called HTTP. HTTP is designed fundamentally for delivering static documents, right, from a web server down to essentially a dumb terminal that displays them. It has a lot of support for things like caching, right, an E tag that tells us, is this document newer or different than something I've previously retrieved? It's a one-way protocol, it's request response, it's stateless. These are all things that are designed with that document model in mind. And of course, what we've been doing the last few years is using it in a very strange way to give us bidirectional, stateful conversations between client software that has intelligence and the trusted server environment that still holds the data that that software needs. So I think the ideal version of this is a WebSocket, but of course today WebSockets in the field have a number of downsides, and so we've used various tricks involving XHRs, script tags that return parsable JavaScript, all kinds of other things, right, so that we can mimic a stateful back and forth conversation between the client and the server. Well, it's probably no surprise that there are a lot of rough edges to doing things that way, and I think most of us run into some of them as we build our apps. It's not so hard to do an XHR and get back some data from the server. It's not so hard to consume a REST endpoint from your JavaScript on the client, but we start to run into some architectural limitations. So for example, there's a round-trip delay to a server, and when your application is far away from the data, it's less and less acceptable to pay that round-trip delay every time we need a piece of data from the server. And I think we sense that. I think we see that when we try to consume a REST endpoint from a JavaScript library on the client, it kind of works, but we end up building an ad hoc cache of some kind. we find that that cache now gets out of date, and so we have to build some sort of system where the server can push updates to the client in real time. And when we hear about a real-time web, what we really mean are these invalidation messages, this ability to push information down to the client when the client has no reason to know otherwise that the data has changed. And fundamentally, what Meteor is a platform that we've written that captures the best practices for how to do this in a way that thinks about the problem from first principles. So rather than holding on to a lot of the legacy technologies and a lot of the old practices for structuring an application, REST, for example, being one of them, we've built a platform that's designed around the client being a first-class piece of software and a protocol that allows the client to communicate in real time with the server that it depends on. So if you watch the screencast at Meteor, or if you play around and see how quickly it is, and maybe we can get into some of this as a live demo in a bit, how quick it is to build an app where you have multiple browsers looking at the same data, the screen updates automatically when someone makes a change, it's secure and it's scalable. The reason all of that is so fast and easy to do is because we've started from these first principles and built protocols and packages that work well together in that new environment. Okay, so with that as context, it's worth talking about the roadmap of where we are and what's coming for 1.0, and then I want to dive into packaging as an example of a case where rethinking some of the existing practices can be really valuable, and I think what we've come up with and what's available now in the release is a more productive way to write software that has both a client and a server component. So there's a few things I wanted to highlight as I think the major things on our mind between where we stand today and what I would call a 1.0. That roadmap at roadmap.meteor.com is actually a Trello board, so I would encourage you to go there and please leave comments and vote on the things that are most valuable. There are certainly some things I've left out here. Internationalization, for example, has become a highly requested item. But I think these 7 really capture the key components that we want to deliver a really seamless developer experience for. And there's a lot to say about all of them, but for today I really want to focus on the first and the last, on packaging and on testing, because they go very well together, and this is what we have been focused on as part of the 0.6.0 release process for the last few months. And again, I want to leave plenty of time for your questions, so I'll do an overview of what's coming and show you a few things on the command line, and then just jump right into Q&A. So Meteor 0.6.0 is available as a release candidate today. There's you can install it and use the release version. I think it'll go out later this week in general availability. The major change in 0.6.0 is a move toward what I would think of as a distribution model. And this is something that has been present in Meteor from the beginning, but not something we've talked a lot about. And I'm hoping to use today as an opportunity to share some of our thinking for really how that works. So I think of Meteor as a couple things put together. One of them is a collection of what we call smart packages. These are individual libraries, individual units of functionality. That's the first thing. And the second thing is a tool, a packaging tool, that bundles them all together into a working app. Maybe you can think of it as a combination of NPM or your favorite package tool plus make or SCons. So I think of a Meteor app as something that looks actually a lot more like the old Unix applications that we wrote in C that had lots of libraries rather than a web app, in the sense that the Meteor tool is a linker. It takes the different packages, pulls out the pieces that you need, and then bundles them into a JavaScript, almost looks like a library, right, that we ship down to the client and run on the client. So when we think about packaging, the architecture I described with software on the client is, I think, vastly more complex in some ways than what we were running in the old server-centric environment. And let's touch on what that means, right? One of them is that we literally have millions of copies of our application running at the same time in the case of a large web scale application. I mean, literally a million copies, right? And they're all running on slightly different platforms. So I have varying JavaScript browser VMs, of course, on the desktop. I've got another set of environments on my mobile devices. And potentially those mobile devices are running native code that talks to the same server. Or potentially, as I said, they're running something like Titanium or some other embedded JavaScript. And I've got servers that are potentially in multiple data centers, different parts of the world. And as I mentioned, the networks between these things aren't as good as we'd like. When we're used to writing software in the server environment, we can trust that the networks between our different components, between our app server and our database, for example, are fast and reliable. That's not the case when it's the network between my mobile phone and my web server on the other side of the world. So it's a different environment. And the crazy thing is we have code that's actually shared between both, right? So in the modern JavaScript application, we might write model functions and validators and other routines that are literally shared. The same exact code runs on both the client and the server. And so that demands, I think, a different way of thinking about packaging than what we're typically used to, where packages in the Node or the Ruby world or in RPM land are essentially tarballs of files. We have a bigger problem to solve here. And so I want to talk about 6 things that emerge as principles for what a package system designed for a client-centric environment looks like. And I want to start with this idea that we have these 2 environments, that we've got client code and server code. And the package answer has to be equally comfortable with both. So if we are comfortable with server-side JavaScript programming, certainly we know about NPM. And when Meteor was released, a lot of people asked why we didn't use NPM as the native package format for the Meteor packages. And the answer comes down to this client-server duality. On the server, NPM is a clear winner, I think. But packaging for client-side JavaScript is actually quite a bit different. And there's some other technologies that have emerged as potential candidates. Volo and Twitter has Bower. There's asynchronous modules. There's a number of different approaches that people have looked at. And frankly, the most popular, I think, still today is wrapping your whole JavaScript file in a closure and just linking to it. Right? That's packaging on client-side JavaScript today. So we want something that's flexible and that can work across both of those. So what I have on the screen here is an example of a package descriptor in Meteor for the underscore package. This is about as simple as it gets. It's one JavaScript file that runs without modification, either in the Node environment or in the browser environment. And what we have is we have a package.onUse call that, in this case, says the package is available on both the client and the server. And that's that API.add_files that takes a parameter which we've set to both client and server as the set of environments where it works. This is what packaging needs to look like if you want to have a consistent environment in both places. And so in Meteor, I can type Meteor add underscore, and the underscore library becomes available to me both in my server-side code, where it's been loaded as a Node package using the require style, and on the client, where it runs as part of the bundled up, uglified JavaScript bundle that we send down to the wire. So that's the first requirement. The second requirement is, as I said, Meteor is, I think you can think of it as a build environment and a linker as much as anything else. And packages need to have a role in the actual build step of the application as well as the runtime. So we can think about the code you write that actually runs your application. But we can also think about a package like CoffeeScript, which actually doesn't do anything at runtime. CoffeeScript is JavaScript that runs during development time and takes a coffee file that I've written and emits the equivalent JavaScript. So the CoffeeScript smart package, and let me just put that up for you, actually registers an extension if you look at the bottom of the screen, and then runs a handler whenever the build environment encounters a file that matches that extension. Right? So here's an example of how now I type Meteor add CoffeeScript, and automatically the files in my project that are coffee files or literate coffee files are compiled on the fly. And if they change, the build system automatically reruns this so that you get new versions of your files compiled in real time. So there's lots of examples like this. Stylus and Sass and other preprocessors all fall into this category. We also have in Meteor packages that alter the configuration of your project. So you can use a package as a way to specify deploy settings or other things that affect the development environment rather than the runtime environment. And speaking of deploying, you really want your package to be able to affect the environment that it runs in production. So thinking of the set of servers and the set of resources that we have available for the application as a first-class thing that the package system understands. So one example of this would be sending email. So we have a smart package in Meteor called email, and obviously that sends code to the server environment that allows you to do email.send and then deliver an email. But the other half of the story is that to send email on the real internet, you need a bunch of other stuff, right? You need some kind of SMTP endpoint that you can talk to, and you need to provision that endpoint. Well, the idea of a smart package is that the package configuration itself ought to describe those resources. And so today when you do Meteor deploy and you ship an application that includes the email package, the application container automatically provisions an SMTP endpoint for you to send mail to. So you can seamlessly do that just by typing email.send in your code. That's something we'd like to make more generic and available as part of the packaging API. And that way you can define a package that actually influences the set of resources available once it's deployed on the public internet. Another example might be an incremental search box. So imagine a widget where I have a text box and I can type, and as I type, I do type ahead search and return a set of results in some drop-down window. So that clearly involves some client code. That's where my HTML templates are defined and so forth. It probably has server code because I need to run methods on the server to query the database as I type. I'm not going to ship all the data I'm searching down to the client in advance. But in the extreme case, it probably means a Lucene server, right? Or it means a Postgres module that does full text indexing. Or at the very least, it means setting up a certain set of indexes on your database in production. And so the smart package format needs to be able to tell that deploy environment about these configuration settings in a way that's not part of your application, but it's actually part of the package that you've added. And it's the same for any application that would use that package. The fourth thing that I think is very important, and that gets back to the principle of making application development super easy, is curation. And so one of the things we want to do with Meteor packaging is make it easy to see a set of packages that work well together and have been tested against each other in a more structured way, I should say. So you can think of this as the paradox of choice, and I think the rise of lots of small modules that do one thing well has been a great trend, but also actually causes challenges for developers with respect to this. So I have a screenshot, for example. I hope this is big enough to see. So I recently ran into this problem where I wanted to parse some XML on the server side of my application. And if you search for XML parsing in NPM, you actually find a lot of options. We have HTML parser with less explosions. That sounds good. We have a parser that's forgiving and runs in both Node and the browser. We've got parser number 2, which is also forgiving. And this kind of thing comes up all the time, right? So this is a challenge for me as an application developer because I don't know how to think about which of these packages I should be using. And in my experience, what I tend to do is look at them and actually look at the code and see which one actually feels like the right fit. But realistically, that's not what I want to be doing most days. And I think this is an example where a little bit of curation and the ability for the community to surface popular packages and flag them as reasonable defaults in the package system without preventing people from submitting any variation that solves a problem or takes a different approach or whatnot. I think that becomes more and more important, particularly when, again, we have this explosion of smaller modules and a typical project may have a dozen or 2 dozen separate packages in it. And what comes along with that is release engineering. So what I'll show you in a second is how you can think of the Meteor distributions as a set of packages that we have release engineered as one. And they work together, and they've been QA'd against a bunch of different browsers and in a bunch of different settings so that you have confidence that those packages are compatible and are tested well together. The way I think of this is release engineering isn't something we should push onto the shoulders of the application developer. It's really a responsibility of the platform, I think. And I think we've lost sight of that to some degree. Again, the ability to quickly and easily publish packages is fantastic, but I think the downside of that has been sort of this expectation that each individual application author or each team of developers is going to take responsibility for their own QA cycle, not just of their code, but anytime they take an update. I think that's a step backwards. And so what we are doing in the Meteor packaging space is giving you pinned versions of packages that we have tied together in a QA process and then called a release. And so you can use that, and you can use that knowing that those pieces are tied together. And the other half of that is ensuring that every copy of your application uses exactly those packages at exactly those versions. And so we think it's very important to pin packages to specific versions, and that gives us what I call repeatability, or the way that you can know that my checkout and your checkout and my deploy and your deploy aren't using subtly different versions of a downstream dependency that someone updated while we didn't realize that was happening. So in Meteor, when you add a package, you are tied to a specific version and to a specific version of its dependencies all the way down the chain. So those are the 6 things that really, for me, sort of set the stage for what we want in a modern packaging system. And what I'd like to do is show you how a couple of these things work in 0.6.0 and then just take some questions. OK, so let me create just an example application real quick. And if you haven't seen Meteor, I'll just spin this up and I'm running an application called Leaderboard. This is one of the examples that comes with Meteor. It's, I think, like 30 lines of JavaScript or something. It's, we've got a list of people on the screen, and I can click a button to increment the score. And if you haven't seen Meteor before, the neat thing about this is that everything is persistent. So as I make a change in one browser, the same result happens in the other browser. And my screen is very small, so forgive me, it's hard to get all of this on at once. But there we go. So again, I increment the score on one side, and it happens on the other. So I'm running a version of Meteor, and I can ask what version. I'm running 0.6.0 RC3. So the first thing that happens in 0.6.0 is that I can individually track Meteor versions per application. So rather than installing a particular Meteor version on my laptop and then using that everywhere, each application has its own version. And I can actually run my app against older versions of Meteor. So I can do Meteor -- release, and I believe there's a RC2, for example. And I'm now running the same application against an older copy of Meteor. And I haven't changed the configuration of the app. The app is still built against 0.6.0 RC3 because that's the version I have on my laptop when I created the app. But I'm temporarily running against an older release just to see if it behaves the same. Maybe I found a bug and I want to make sure it's not an update in the actual version of the software. I can even downgrade, so I can update the application permanently to use release RC2. And then, of course, I can run against a newer copy. One of the neat things that this lets us do is we can now ship test releases that fix particular bugs, for example. So I'm not limited to 060 RC3, right? If someone reports a bug, we can cut a, Meteor fixes issue 207, and then just say, try running your app with Meteor run -- release fixes 207, and let us know how it goes. So one of the big advantages, I think, for us is going to be able to turn around fixes and do release engineering on a much faster time scale, because we can narrow down these differences to much smaller variations in the release. So that's the first thing I wanted to show you. Second thing I'd like to show you is internally how these releases are put together. So I have a checkout of Meteor, and actually I'll show you this. So my install of Meteor in my home directory has a couple directories in it, and I'll go into the releases directory for a second, and I'm going to open up the configuration for 060 RC3, which is what I'm running. And the only thing in this file is a version of the tools. This is the command line bundler, the Meteor command line tool. And then a manifest of packages that are part of 060 RC3, where each package has a particular version, a SHA, right? And that's it. The entire release is just a manifest of what these packages' versions are tagged to. So again, an app on 060 RC3 is precisely these packages, and I can go in and show you in the packages directory what each of them looks like. So let's take a look, for example, at Mongo Live Data, for example, which is our gasket between the Mongo database and the wire protocol that Meteor apps use. And inside my package configuration, I have a dependency on MongoDB 1213, which is a server-side node module that is the Mongo driver. So I talked about pinning versions of packages. Let me show you what that really means. I'm going to see if I can do all this on one screen. So I'm in the application I created. I'm going to run Meteor. And while my application is running, let's say that I'm working on a fix to the database package, or I'm taking an update, and I have a bug, and so I want to downgrade my package. Oops, forgive me. I have the wrong file open. Work Meteor packages, Mongo Live Data package.js. And let's say I want to downgrade to version 1212 to look at a performance degradation or something. So I save the file, and in real time, Meteor is going to notice the dependency change on the NPM module, fetch the new version of the MongoDB NPM package, shrink wrap that so that it's tied into the version of the application I'm running, and then restart and do a hot code push for my app. And so I still have my app running, and I hope that that version of the driver doesn't, change it. But now I can test my app against an older version of the same driver, and it appears to still work. That's great. And I can go back. Maybe it was 1.2.10 that was actually better. And so again, Meteor will restart, fetch any necessary packages. And when that happens, Meteor is generating that shrink wrap file that I mentioned. So internally, what we have is the Mongo Live Data package that I'm running has determined 1.2.10, which of course came from my configuration. But that also depends on the Beeson package at version 0.1.5. And I'll just go back and go back to the original 1.2.13, update my server once more, and if I revert, I see that the dependency bsin also changed automatically based on this new version of the Mongo driver and which package that it used. So this is an example of how we can pin a specific package and use different versions of that package. Let me show you something else. So let's continue to look at this package. We have a test framework that lets us look at package testing. So I want to do Meteor test packages, and let's say that I'm interested in this Mongo live data package that I'm running. So test packages spins up an application, and this is actually running a test suite that covers the behavior of that package. And so now on localhost 3000, I actually see the regression test suite for that particular version of the live data package. And as tests run, I can see that they pass. And I'll give you another example of that. I can come over here. Let's open up the mini Mongo package, for example. And let's see if I can break something. So I'll open up the selector implementation. Actually, I'll tell you what I'll do. I'll go to one of the tests for mini Mongo, which is our in-browser database, and I'll just change one of the assertions. And I can run the mini Mongo test suite. There's a failure. And if I change this test back, I should see the test update in real time automatically and show that they're passing. And again, all of this has been pinned down to the version of the package that I'm running as part of my app. So it simplifies the release process by letting me, again, try a different version, do a temporary release if we need to, have people update to that release temporarily, and if that works, then we can promote it to RC2, RC3, and so on for a final release copy. The last thing is what I touched on before that I wanted to show you is the use of NPM in the packages. So in 0.6.0, Meteor packages can depend on NPM packages. And so just to go back to that example and show you how that code works, in my Mongo package, I have a control file line that says this package depends on the NPM MongoDB module. And then in my driver, I can just call npm.require to fetch that version of the package. And again, it's been pinned to the 1.2.13 that I already described. If I had another package in my app that also required the MongoDB driver, there's no requirement that those two packages use the same version. So when I bundle up each Meteor Smart package, it's going to calculate its dependencies separately and package those up. So I can actually have multiple versions of those dependencies in use at the same time. The point is that each package defines the exact components that it needs to use for running according to the way the package author thought was correct. And then the Meteor release defines a specific version of that Meteor package that you can use in your application. And so that's the gist of 0.6.0. It's an update to the tools so that Meteor is a distribution of packages, very much like Ubuntu or Red Hat. I can use whichever ones I like. I can update them separately, but the guarantee with the packages out of the box is that they've been release engineered together so that all of them work well together, and more of that burden is on the shoulders of the platform developer and the package developers and less on application development. So that's what I wanted to show. Happy to take questions, and thank you.